Okay, so find the quotient and the remainder using long division for this. Basically, here's the story. When the denominator has only one term, then long division is not needed. Simply put that term under each part, right? If you just had one, so like if we didn't have the plus 5, for example, if we just had 2x squared, then I would just put that 2x squared under this guy, under this guy, under this guy, and under this guy. It would just be 2x cubed over 2x squared minus 12x squared over 2x squared plus 7x over 2x squared minus 23 over 2. So it would be a piece of cake like that. Then I would just cancel. 2 cancels 2. X squared leaves x to the first there. And 2 goes into 12. 6 times x squared cancels x squared 6 plus. And then here, x cancels x squared, leaving x to the first down below. And then this would stay 23 over 2x squared, and we'd be done. That's all there is to it. You know, wouldn't be a hard deal at all if there was only one term in the denominator. But in our case, there's not just one term in the denominator, there's 2. So we can't do that. We have to actually do long division, which means you put the 2x squared plus 5, you go bottom into the top. Because we have 2 terms in the denominator, 2 or more, right? We don't just have one term. We have more than one. Okay, so then put this inside 2x cubed minus 12x squared, 7x, whoops, minus 23. Okay, so I'm going to do long division, bottom into the top, because I have to when we only have, when we have more than one term in the denominator. So how do I carry out this long division? How does it work? Well, remember where you look. You look at the front and the front, don't you? Whatever goes up here is going to multiply the front and match the front. Now, if that seems strange, just remember what we do for number long division. Like if I was to go, I don't know, 21 into 8, 4, what? I don't know, 6, 9. What would you do? You wouldn't worry about everything. You would just look 2 and 8, wouldn't you? Just go, oh, okay, 4 times, right? And you'd go 4 times 2, and then it would multiply both those guys. 4 times 2 would be 8, 4 times 1 would be 4, like that, right? Or even if, let's say this is a 5, let's just change it to a 5. And then you would subtract and get a remainder of 1, and then bring down the 6 and the 9, or you can bring down 1 at a time, whatever, either way, right? That's how that's how number long division works. You've done that before. So think about what you did. You looked at the front here and the front here, and you say, what do I put up on the top that'll multiply to the front and match that? So it's the same thing when it comes to letters. What am I going to put up here times the front that will match the front? Just worry about the front. Don't worry about all the other stuff right now. Just focus on the front and the front. That's what you do with numbers. 4 times 2 is 8. So what am I going to put up here? What times 2x squared will exactly match 2x to the third power? Remember how multiplying with letters and things works? You multiply the numbers in the front, add the powers. Remember that? Multiply the numbers in the front, add the powers. So if I put up here x to the first power, that'll do it. And it's going to multiply both those, just like this 4 multiplied the 2 and the 1. So x to the first times is, remember again, out front numbers multiply, powers add. So that'll be 2x cubed. And this one times 5 will be plus 5x. Let me get that arrow out of the way. It's too much stuff. Plus 5x. Good so far. See how we matched the front? And then what do we do from there? We what? Subtract. 8 minus 8 is 0. We don't even write that, do we? And 5 minus 4 is 1. So I'm going to do the same thing here. I'm going to subtract. But you're going to subtract all of them. So you're going to subtract this guy, and you're going to subtract this guy. Just like you subtract the 8 and the 4 for numbers, don't you? These guys are gone, of course. And here we have minus 12x squared, and now minus 5. Oh, wait a minute. Oh, that's in the wrong spot, isn't it? X squared can't interact with regulars. I need to move that down. I didn't even notice that till just now. I was trying to combine unlike terms. That has to go down here. Let me see. What was it at first? It was a plus 5x, wasn't it? Plus 5x, but then I subtracted, so it became minus. Yeah. So you have to line up the like terms. This is going to be x cubed. This column will be x squared. This will be regular x. This will be plain numbers. See how it goes from highest power, third, second, on down to lowest, regular x, and then just numbers. So is that good so far? This x in the front went there and there, becoming 2x cubed and 5x. And I just lined up these guys, and then I subtracted all. That's what you got to subtract the whole line. So make that minus and that minus. I'm circling the new signs. And so we have, right here, we have 7x minus 5x. So what does that leave? 2x, right? And then just bring down the minus 23. Is that good so far? Oh, and I forgot this guy. Bring that guy down too. All right. Now, next step. What are we going to do? Well, think about numbers. What would you do with numbers? What would you write right here? Times the 21 if you had 169 down here. What would we do? Well, we would say, what times 2 can go into 16? We'd say 8, wouldn't we? What times 2 makes 16? 8. Same thing here. What times 2x squared exactly matches? Remember, it's got to be an exact match. Same sign, same everything. So what's it going to be? What times 2x squared exactly matches minus 12x squared? Anybody?
Would it be negative 6?
Yeah, good job. It's got to be negative 6, right? So negative 6. That's exactly right, because it's got to be the same sign. So that's a good job. It is negative, because negative 6 times 2x squared makes negative 6x squared. And then it also multiplies the other guy, remember? That'd be negative 30. And I'm going to write that negative 30 down here because it's got to be in the plain numbers column, doesn't it? Good so far. Draw your line. Now, what are we going to do? Subtract all. Remember? You're subtracting all. Well, how do you subtract all of this line? How do you subtract a whole group of things? That minus sign distributes, doesn't it? And this becomes plus, and this becomes plus.
Is that negative 6x supposed to be negative 12x on the bottom right there?
Yeah.
Oh, yeah. Sorry. I'm just being totally goofy. Thanks. Exactly. 12x squared. Yeah, thank you. It's negative 6 times 2x squared. Yes, should be minus 12x squared. Thank you. And then negative 6 times 5 should be negative 30. And then they're both changed to positive. Why? Because I'm subtracting them all. It's like It's like having a minus sign in front of minus 12x squared minus 30, right? You know what happens if you had a minus sign in front of the whole group. You'd go boom, boom, and it'd be plus 12x squared plus 30, wouldn't it? That's how you subtract a whole group. If the group's negative, it becomes positive. So that's what just happened there. That's a lot of the part that confuses people right there. Is that making sense for you? So I'm subtracting all this minus sign, has to go there and go there, subtracting both of these guys, changing both their signs to positive. Okay, and then these cancel, minus 12x squared now plus 12x squared. That's, by the way, that's how that works, huh? We make it exactly the same at first, same sign, same everything, matches, but then when we subtract it, it changes to be the opposite, so they add up and become 0. Perfect. Now over here we have minus 23 and now plus 30. Whoops, I bumped the thing there. So that's going to be 7. And bring down the 2x to plus 7, isn't it? Everybody see that? On the signs there, this is a plus 30 because it was originally a minus 30 because minus 6 times 5 made minus 30, but I changed it to plus. What the subtraction did, we're supposed to subtract the bottom line. When you subtract a negative, it becomes positive. So minus 23 and plus 30 is plus 7. Bring down the 2x. Okay, we're actually done. That's the remainder. Well, how do you know you can't go another line? Shouldn't we go another line? No. This power is higher than that power. We're done. In other words, what could you ever put here that would multiply 2x squared and match 2x? No way. You got to make the power smaller somehow. You got to make it go from x squared just down to regular x. There's nothing that'll do that. Well, I mean, you can multiply by a fraction or a negative power, but we're not doing that. We're not doing any of that. No, we're done. This is remainder right here. This is all remainder. And the way we know this is remainder is because the power is lower than the 2x squared plus 5. It's lower than the 2x squared plus 5, the power is. It's just 2x to the first power, whereas this is x squared. So as soon as you're lower, as soon as your power is lower, that's a remainder. That's a remainder. Just like if we're doing number long division, let me finish that and then number one up. I put an 8 here. 8 times 20, 21 would be 168. Subtract 1. That would be the remainder. Why would that be the remainder? Because it's lower. Whoops, sorry. Did I just hit something weird? There it is. Hitting a lot of weird buttons today. Sorry. It's because it's lower than 21. That's how you know you don't go in again. Well, same thing except for powers. 2x to the first power is lower than 2x squared. Power, the power. It's all about powers when you get to letters. So that's the remainder. So what's the answer to this question? So we are done. The quotient is x minus 6. It's right here. Is the quotient, and the remainder is the 2x plus 7 right here. This is the quotient. And so that's exactly how we do that. Here we go.